chicka, bow, wow, ew, bow, wow, jow, bow, chicka, wow, wow.
All right, we can continue with unit on trigonometry, and we're going to look at the trigonometric area formula today. Not surprising, the trigonometric area formula helps you find the area of a triangle. So the trigonometric area formula, also called the trig area formula, allows you to find the area of a triangle if you have two side lengths and the angle between those two side lengths. So side, angle, side. And if you remember back to when we looked at congruent or isometric triangles, if we have two sides and the angle between, those triangles would be the same size and therefore would have the same area. And again, I can't stress enough, it's not any two sides and any angle. It has to be two sides with the angle in between. And now, you've probably looked at the area formula for a triangle. Area equals base times height divided by 2. Most people start with that one. And so this trig area formula is really just a kind of an expansion or extension of that formula. So if we look at this example up here, we're asked for the area. We've got one side of 11 centimeters. We have another side of 5.5 centimeters. And we're given an angle of 50 degrees. Now, not right off, we couldn't use base times height divided by 2 because we don't know the height. However, we do know the base. So I'm going to go down here, and I'm going to fill in our base, which is 11. We still need to find out the height and go from there. All right, so we need to find out the height in order to calculate the area. And I'm going to draw in the height, which would be right about there. Let's straighten this out. Straighten it out. There we go. And of course that would meet at a right angle down here. So it creates two right angle triangles. And so we want to find out the height. And with what we know of trigonometry now, we should be able to look over here and realize, well, wait a minute. We have a right angle triangle. We've got another angle, 50 degrees. And we have a side length. So everything we need to do right angle trigonometry using SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now you could do it with sine law as well, but it's a little bit easier to see where the trig area formula comes from if we use right angle trigonometry, so I'm going to stick with that. So if we go over here, we can label our sides. So the 5.5 represents the hypotenuse of this triangle. Across from here, the height is the opposite, and the side left over at the bottom is the adjacent, which is, again, just this portion here. It doesn't go all the way over. So we look at what information do we want and what information do we have. Well, we have the hypotenuse. We want the opposite, so we'll use sine. So I'm going to go down here. Oops, pardon me. And we'll write out our sine formula. So sine theta equals opposite over hypotenuse. After that, I can fill in my values. Theta represents my angle. So I have the sine of 50 degrees. My opposite, that's what I'm trying to find out. And that represents the height of the triangle. So I'm just going to write it in as height. And I prefer to write it in as height rather than h, because sometimes if you put h, you might just confuse it with the hypotenuse. So I'm going to spell it out here. And then our hypotenuse in this case is 5.5. After that, we do our algebra. So we multiply both sides by 5.5. And we have the height equals 5.5 times the sine of 50. And then we can bring up our calculator. Slide over. So you have 5.5 times the sine of 50. Make sure when you're doing trigonometry with the calculator that you're in degrees. So we're in degrees here, so that's good. So we have 5.5 times the sine of 50, and that gives a value of 4.21. I'm just going to go with 4.2. So our height of this triangle equals 4.2 centimeters. And now we can just go over here, fill in our height of 4.2. So we'd have 11 times 4.2 divided by 2. And again, we can bring up our calculator. Times 11. So 46.35. Notice I just left my value here. That way, even though I only wrote down 4.2, it uses our more precise calculation. So it gives us 46.3 or 46.35. So divided by 2. And we can find out our area here. So 23.2. I'll just go to 1 decimal. So our area of this triangle is 23.2 square centimeters. So that's nothing too challenging. We basically took our area base times height divided by 2 formula. We used trigonometry to find out the height and went from there. So let's take a look at this, except now rather than using specific numbers, we're going to look at it using algebra, where we're basically replacing everything with letters. Now if you look at how things are labeled, we labeled it just as if we were doing sine law. Remember, when we do sine law, we use capitals to represent the 3 vertices of our triangle, and then the lowercase letters A, B, and C represent the side opposite each of the angles. So A is matched up with A by the side that's opposite, so on and so forth. And now let's go through the exact same steps that we did before, only this time algebra. So we've got area. I'm going to write out area so we don't confuse it with the sinus. Equals base times height divided by 2. And again, I'm just using the words here rather than the letters so we don't have any conflict. So our base in this example is going to be B. So we can go down here and we can replace our base with B. So we still need to find the height. So I'll leave that in, times the height divided by 2. And then, well, how did we find out the height before? Well, we use sine. And the same thing happens. If we're looking at angle A, this would be my opposite side, and this would be my hypotenuse. So we went before, we said, all right, well, the sine of theta equals opposite over hypotenuse. And then, well, wait a minute, before we have 50 degrees, now all I have is A. So I'm just going to write in the sine of A. And again, I get it that that's kind of hard to imagine what that is, but all that meant is that if this angle over here had been 40 degrees, we would have put in sine of 40. If it was 70, we would have put in sine 70, 53, sine 53, so on and so forth. Since it's 8 degrees, we're just going to put in the sine of A. Whatever that angle is, we would put it in for our angle. Our opposite, well, that's still representing the height of the triangle. I'm going to write in its height. And the hypotenuse, well, we can see that now that's represented by the lowercase c. So I'm going to write in c. And then we did our algebra before, and we had c times the sine of angle A. Again, in the example we just did, our c was 5.5, angle A was 50. So we have 5.5 times the sine of 50 degrees. But here, we're keeping the letters so we can see the patterns. So if we look at our trigonometric area formula, all we need to do now is replace the height here with what we have over here. So we have B times C times the sine of angle A, and then divided by 2. And again, as I said initially, we got side, angle, side, 2 sides and the angle between. Now, often you'll see 2 other formulas written out for the trig area formula as well. I'm going to write them here. We could also have A times B times the sine of C divided by 2. Or we could have A times C times the sine of B divided by 2. And that can be a little confusing to think, well, wait a minute, we actually have 3 trig area formulas. But if we take a look, it's really all the same. I could have these 2 sides and this angle, AC and angle B, AC sine B. Or I could have these 2 sides and this angle, AB sine C. Or I can have these 2 sides and this angle. It really makes no difference. And that should make sense because this could have been labeled with the letters in any order. So even though it's 3 formulas, it's really just worked as one. All right, so let's take a look at a couple examples. So here we go. We've got 2 side lengths, and we've got an angle, and it's the angle between the 2 sides. So we can do the trigonometric area formula for this one. And again, what we'll notice is that it's really just a shortcut to find out the base. So I've written all 3 of them, 3 of our formulas here. And first thing I'm going to do is I'm going to label the triangle A, B, and C, capitals for the vertices, and then lowercase letters to represent the sides opposite. So over there will be lowercase a, down here will be lowercase b, and then over here will be lowercase c. And so for my formula, some people find tricky, well, which one do I want to use? So I just need to look at the information I have. Here I've got b, which is 11. I've got a, which is 8.5. And I've got angle C, which is 30. So which one has sides A, B, and C? Well, it's going to be this one here. So I'm just going to now take my values and fill them in. 8.5 times 11 times the sine of angle C, which is 30 degrees, divided by 2. And we can do that all in one step on our calculators here. 8.5 times 11 times the sine of 30 divided by 2. And we get an area of 23.4 centimeters squared. And there you go. That's it. Thanks for watching, and I hope this helps. Have a good day.
You're still here? It's over. Go home. Go.